Alrighty, geometry students, howdy howdy. We are going to begin chapter 3. So this is 3.1. And from now on, you'll only have one video per lesson, and that's the homework going over definitions and questions because we will be doing the exercises in class where you can get in-person help rather than just ignore these videos. All right, here we go. So here's our first homework, definitions. We're going to be talking about lines and angles, in particular, these things called transversals. And so let's jump right in. But kind of the key is learning to identify different relationships between lines and their angles. So let's look at our first definitions here. First one is parallel lines. This one you're probably familiar with. A parallel line are two lines that are coplanar. So they lie on the same plane and they never intersect. So any two lines that are on the same plane but never intersect, we call coplanar. So I've drawn this little cube here that's just like the one in your book in order to illustrate some of these line relationships. So for example, we have line here, AD. That would be parallel to line BC. So an example, if we want to put an example of parallel lines, we could say line AB, and then here's the symbol for parallel, so you don't want to have to write out P-A-R-A-L-L-E-L over and over and over again. We just put two lines, vertical lines like that. Okay, so that means line AB is, and actually I've written this wrong. It's line AD is parallel to line BC. Okay, so again, that would be this line and that line. Those are parallel. Also just pointing out that we also have line FE. That would also be parallel, and even line GH there in the back. All of those lines are parallel to one another. So we could list those as examples as well. And then of course you don't want to forget, you could also do a line like this, line BF and line CE. So I'm just going to put another example. Why not? BF is parallel to CE. Okay, so that is parallel lines. Oops, okay. So then that takes us to another type of line, and that is perpendicular lines. Perpendicular lines, they intersect at 90 degrees. So they form that T shape, or what we might think as a corner, or again, a perfect T, where they form right angles or 90-degree angles. So perpendicular lines would be something like, say, AD here, and then DC. That's why I drew this as a cube, because they would form a right angle right there. So we'd have, and then we could write that as AD, line AD is perpendicular, and you just draw a little T, or upside down T, basically, like that, and then DC. They are perpendicular. And again, you can find other examples, AC back here, or I'm sorry, AG and GF. Those two lines are perpendicular. Again, it looks kind of like a wider angle, but just imagine that's the depth drawing of a cube. If you look straight down on AG and GF, they would also form a 90-degree angle. So we could also give another example, like AG is perpendicular to line GF. Okay, so we have parallel and perpendicular lines. And then our next type are skew lines. Okay, skew lines are basically don't fall into the previous two categories. They are lines that are non-coplanar, so they don't lie on the same plane. In other words, you couldn't create like a surface between the two lines. They're not parallel and they don't intersect. So this can be a little trickier to identify, but let's take a look up here. Let me pick a new color for skew lines. So what that would be something like, let's take AD here in the front. A skew line would be like HE in the back, because you can see even though my two lines hit each other, if you're picturing it in 3 dimensions, you've got AD here in the front and HE going behind it. They're not parallel. They don't intersect because it's actually behind the other line, and they don't form a surface because there's no way to connect them, like almost like with a sheet that would be a plane. So that means they're non-coplanar. So AD and HE are skew. Let's see, just another example might be if we take FE right here, you can see GF intersects with it, so we can't go with that. BF intersects with it. AD here in the front is parallel to it, so that wouldn't be skew. But if we did something like HD, so FE and HD would be examples of skew lines. And so I'll go ahead and go with that one for our example down here. FE and HD. FE is skew. Now there's no symbol for skew. Maybe you want to make one up, some sort of squiggle or something. FE and HD. Oh, we should say is skew to line, and it is HD, right? Yeah, HD. Oops. Okay, so they're not on the same plane, and they don't intersect, and they're not parallel to each other. That's what skew lines are. Okay, and that we'll leave our drawing behind for another topic, these things called transversals. Transversals, it's a transversal is a line. This actually is incorrect. Let me fix this, right? A transversal is a line that intersects two coplanar lines. Okay, so what does that look like? We're talking about there's two lines here. These two lines lie on the same plane, and then you have a third line that crosses both lines at different points. I might even add that here, at different points. So basically you have one line crossing two other lines. Okay, again, another simple example, you could draw it this way. If you have two lines that are coplanar, and then it's a transversal when a third line cuts through those other two lines. Okay, the other two lines could eventually intersect. They don't have to be parallel. I'll draw a smaller version. They could look something like that, and maybe these actually crossed here. But then if this line went across them, hitting at these two distinct points, that's a transversal. Now we're just introducing that because we're going to learn that within a transversal, again, two lines crossed by a third line, you get some interesting angle relationships. And so that's why you want to have you want to be familiar with, well, when we say the word transversal, what we're actually talking about. Again, a line that intersects two coplanar lines at or at different points. All right, so let's learn some of those special names for a transversal. So over here off to the right, I'm going to draw a nice big transversal. I'm going to go ahead and, so there's one line. Here's another line. And then here's a third line that intersects both of the other two lines. And I'm going to number the angles within this because we're going to learn that they have a special relationship or name to them. So I'm going to go 1, 2, 3, 4 are angles formed by that intersection, and then 5, 6, 7, and 8. Okay, because we're going to reference these numbers to define these last couple. There's a lot of definitions for 3.1. Okay, so we have this thing called, in every transversal, so all of these definitions here rely on you having a transversal, two lines being intersected by a third line. Kind of like the letter A, I keep making with my fingers. So alternate interior. So alternate interior angles are the two angles inside of the two coplanar lines, in between them, and they're on alternate sides of the transversal or the crossing line. So for example, all the interior angles are these four right here, 4, 3, 5, and 6. Those are the interior angles because they're inside of the two lines. When we say alternate interior line, then we're talking about like 4 and 6, because see how they're on alternate sides of the inside? Or we could be talking about 3 and 5. Those could be alternate sides of the interior angles. So for these, you actually don't have to write a definition. Just draw a picture like I've drawn and reference them. So the alternate interior angles would be angle 4 and angle 6, or angle 3 and angle 5. Those are the alternate interior. Again, they're between the two coplanar lines, and then they're on alternate sides, different sides of that crossing line. Okay, and so then we have same side interior angles. And so you can imagine, again, here's our interior angles here. Actually, I want to go ahead and erase these little circles here. But now the ones on the same side. So you have the same group of 4, but when we say same side interior angles, we're talking about these pairs like this. 4 and 5 are same side interior angles, and 3 and 6 are same side interior angles. Okay, because they're still on the interior, but they're not on alternate sides, they're on the same side. Okay, so angle 4 and 5, and angle 3 and angle 6. Okay. Now we're going to repeat that pattern, but it's still very similar. You'll see now we have alternate exterior angles. Okay, so the alternate exterior angles, because now look, we're on the outside. So these are your exterior angles, 1, 2, and 8, and 7. Because look, you have the two lines, they're on the outside. It's really important to kind of get your mind wrapped around that, because otherwise, if you can't tell the difference between these 8 angles and their different names, you'll be miserable all through chapter 3 and even into later chapters. So spend the time for this to settle down, rewatch this video, this portion of the video, if you need to. Okay. So now it's the same, but it's the same distinction, because now we're alternate into exterior angles. So 1 is on the alternate side of the transversal than the other 7, because they're both on the exterior, but they're on alternate sides. So 1 and 7, or yes, 2 and 8. Okay, so angles 1 and angle 7, and angle 2 and angle 8. And then our last group is same side exterior angles. Let's see, we'll go with that. All right, and so that is, if I have 2, then I'm talking about it has that relationship with angle 7, because they're on the outside, they're exterior, but they're same side. So 2 and 7 and 1 and 8 are the same side exterior angles. Angle 1 and angle 8, angle 2 and angle 7. Okay, so you're going to want to be able to recognize a transversal and know if you pick any two pairs of angles, what they are. Same side interior, same side exterior, alternate interior, alternate exterior. And we have just one last one. It didn't fit here, but we have this thing called corresponding angles. Corresponding angles. And maybe I'll just, for the sake, I'll just kind of redraw it so I don't have to keep scrolling up and down. But let's make a transversal. And actually, maybe I'm going to make it this way this time. We've got the two coplanar lines. We'll talk, a lot of times they're parallel, but not always. Actually, I can make that line better. Here we go. You still have the same 8 angle relationships. 1, 2, 3. And I'm not, it doesn't really matter the order you number them. So don't think there's anything that. It's just recognizing how they relate to each other. So like 4 and 6, same side interior. 1 and 8, alternate exterior angles. But when we talk about corresponding, what that basically means is they hold the exact same position. So in other words, if we picture these two intersections, this group and this group, corresponding angles are the two angles that hold the same position. So if you look at 1 and 6, 1 and 6 are both in the top left of that intersection. So they are corresponding angles. Whereas like 3 and 8, they're in the bottom right of those intersections. So they correspond. 2 corresponds to 5. 4 corresponds to 8. It's kind of like if I were to pick up this circle and set it right on top of that circle, whichever ones overlapped are the corresponding angles. Again, angle 1 with angle 6, angle 2 with angle 5, angle 5, angle 4 with angle 7, and angle 3 with angle 8. Those are your corresponding angles. And in 3.2, you're going to find out that they have special relationships. You're going to learn that with whatever they are, these types of angles, you're going to know that they, in terms of how they might equal each other or different things like that. But 3.1, you just want to learn the different names and be able to pick them out of a transversal. Okay, so let's go ahead and get to the questions. The questions, I'm going to pull them up real quick. There's only 2. We're almost done. Okay, so questions 1 and 2 were, how do you identify a transversal? Okay, how do you identify a transversal? You just look for 2 lines, each intersected by a third line. So kind of just putting the definition there. But again, any 2 lines, well, maybe I'll make them even like that. Doesn't even matter if they cross down there. But then if a third line intersects them, then these angles here are what we're talking about, are the transversal. And that's where, again, we can talk about, well, we know something about these angles. They're same side interior, same side exterior, corresponding, etc., etc. So look for any two lines where they're each intersected by the same third line. Okay. Number 2 says, how do you tell the difference between interior and exterior angles? Alrighty, well, I'm going to go ahead and redraw that. Make one, because this is where a lot of kids get confused. Just make it a little bigger so that it maybe is a little more clear. There's a transversal, two lines that are intersected 2 different points by a third line. And the key here is the angles between the 2 lines. So wherever the angles are between the 2 lines, or even better than that, so in other words, those are all your interior. So the 2 lines that are being intersected, all the angles in between, those are the interior. The ones on the outside, these out here, those are the exterior. Or even if I went up to my previous drawing, these are the exterior here, and then the ones inside, okay, these are the interior. You want to get really good at that because, again, it's really crucial this chapter to be able to identify them differently. Alrighty, so the interior are angles between the 2 coplanar lines. Sorry, my penmanship. The exterior are the angles outside the 2 coplanar lines. All right, I used my colors to designate which is which. You could number them or use colors as well. But as an example, show me that you can find the difference between the interior angles and the exterior angles. Okay? All right, I'm going to end this video. It's kind of a long one, but we'll be working on this in class. And you can reference this video if you need it. But good luck. And here we go. Chapter 3 is on a roll.